All right, as we continue in Chapter 5, we're going to move to the law of sines. Now, the law of sines has a couple of different applications, and one that's usually covered in physics and whatnot is the simpler way to see it. But it's an easy formula, but the application, there's what's called an ambiguous case that can be a little bit more challenging. So, very simply stated, it's just that there's a relationship. The sine of an angle over the side across from it is equal for each angle inside in a triangle. So this is in any triangle. If I said this is angle A, this is angle B, this is angle C, and then based on each of the angles and the sides across them, there's this set relationship. Okay? It's very nice if you have a triangle, and it's not necessarily a right triangle, so this is what's great about this application is it applies to things that are not right triangles. So if I knew that I had a triangle and I knew this was 80 degrees and this was 40 degrees and I knew that this side here was 7, I could figure out everything in this triangle because if I just put in x, y, z and called this side x and this side z, then I could say the sine of 40 over x is equal to the sine of 80 over 7, cross multiply and divide, and I would get what x is equal to. I could figure out z by saying the sine of 80 over 7 is equal to, well now I have to calculate 80 plus 40 is 120, so this must be 60 degrees. So I could say the sine of 60 over z. And so I could, again, cross multiply and divide to figure out what z is. I'm going to leave that exercise to you guys. So anytime we have two angles in one side, it's easy because we can figure out the third angle just by doing some subtraction from 180. Now, there is a case, though, that's a little bit more challenging. Well, there's one case. First, let me cover the case that can't be done. If I were to take a triangle and say that, let's see, this side is 5, this side is 6, and this angle is, well, let me go higher than that, 95 degrees. That's not going to be able to give us an answer because when I set it up, I would say, so if I call this angle A, this angle B, and this angle C, and call this side C, I'd be saying the sine of 95 over C is equal to the sine of A over 6, which equals the sine of B over 5. No matter which two I put together here, whether it's these two, or those two, I'm always going to have two unknowns, and so there's not enough to solve it. So in a situation like that, where basically I have a side, an angle, and a side, the law of sines will not help solve things. You have to use the law of cosines, and that'll be the next chapter. I'm going to take a break for now and make another video that will show you how to take the ambiguous case.